So we're doing a video about integrals, and this is us. In the video, we'll be discussing antiderivatives, Riemann sums, the trapezoid rule, the fundamental theorem of calculus, substitution, and integration by parts.
The process of finding an antiderivative is called integration or antidifferentiation. The antiderivative is also called the indefinite integral, and this is the integral sign that we use, and it means the sum of limits. So you'll be given an a and a b, and that will be your limits. And the equation that is used is f prime. We are given f prime of x, and we use that to find f of x as follows. There are three main properties of integrals, and they are listed below. We applied them, each rule, to we have an example. So for the first one, we're given the integral of 7x to the third, and as shown here, we are able to bring the k, which in this case is 7, out to the front of the integral, and then just integrate the x to the third part, which then becomes, we use the equation x n plus 1 over n plus 1. So that's how we get to here. And we multiply that times 7, which gives you 7x to the fourth over 4 plus c. For the next one, we use this, and we are given f of x plus g of x, and so we basically separate them each and solve them, and then add them at the end. So we integrated each of them, and we got x cubed plus x squared plus c. And for the last one, the equation is given here. We are able to integrate the k, which is here, as 5, and we got 5x plus c.
So, this is for the antiderivative. We will use the equation x n plus 1 over n plus 1. For example 1, we have f of x equals x. So to find the antiderivative of f of x, we will have x 1 plus 1 over 1 plus 1, and you will get f of x equals x squared over 2, which is the antiderivative of x. For example 2, if you have a base number such as f of x 2x cubed, you would do the same thing. You would leave the 2 by itself, and you would have x 3 plus 1 over 3 plus 1. Therefore, the equation will be 2x to the fourth over 4, as well as if you have a constant, it would be the same for example 2. So you have f of x equals 3x to the fourth plus 2 there, and then you have f of x equals 3x plus 4, x 4 plus 1 over 4 plus 1 plus 2. Therefore, the equation will be 3x to the fifth over 5 plus 2.
Here we have the area under the graph. For the first step, when they give you an example, they will give you the number of rectangles, so you want to find the width of each rectangle. And then for the second step, you plug the x value in between range a and b into this equation here. It gives you the area. So first example, we have the equations 1 over x. We have a range of 1 to 5, and we have 4 rectangles within that range. So we're going to start from the left endpoints. This will give you an overestimation, and then you plug it goes from 1 to 2, 2 to 3, 3 to 4, 4 to 5, and that means these are left endpoints. So you plug these endpoints into this equation to find the area underneath the graph. You simplify by finding the common denominator, and then you get the area. And then you have to do the right endpoints, so you use these numbers. So you use 2, 3, 4, and 5, and you plug those into the equation here, again, to find the area under the graph, and this is an underestimation. and then you use the midpoints, and to find the midpoints, you plug the left and right endpoint together and divide it by 2, and then you plug these sums into this equation, and then you find the area.
The trapezoid rule is another way to find the integral, and what we use is the change in x equals b minus a over n, and this gives you the width of the trapezoid. And with this, we find the partitions which are formed, and I'll explain that in the example. And then we use b minus a over 2n along with this equation, and that gives us the answer. So for the example, from 1 to 0, we have to integrate 3x squared, and so we are given n equals 4, so we plug in here and we get 1 over 4. So the partitions we use are 0, 1/4, 1/2, 3/4, and 1, so we just add by 1/4, and again we plug in b minus a over 2n, which is given here, and we plug in each partition for f of x.
So next we have the fundamental theorem of calculus, and basically we're just finding the area under the curve by plugging the limits of integration. So the equation is f of b minus f of a, and in your integral you have 2 and 0, and you just plug them into the equation, into this equation, which you just do 2 cubed over 3 minus 2 squared, and you subtract that from the other part of the integral, which is 0, and you do 0 cubed over 3 minus 0 squared, which gives you negative 4 over 3. And for the next problem, you essentially do the same thing, except you're taking the radical off, which is giving you the negative 1/2 as your exponent, minus x to the negative second power, which gives you 2x to the 3/2 power minus x to the negative 1 power, and you get your answer here.
So substitution is similar to doing the chain rule with derivatives. So we have the equation x cubed cosine of x to the 4th plus 2 dx. So you have to find a u, and the u will be x to the 4th plus 2. Du over dx will be 4x to the 3rd, and du is 4x to the 3rd dx. So you have the equation, the integral of x cubed cosine u du divided by 4x cubed. So you have to bring your 4 out in front of the radical, so it will be 1/4 x to the integral of cosine u, and you will get 1/4 sine u plus c, which equals 1/4 sine x to the 4th plus 2 plus c.
So here we have integration by parts. You have this lengthy equation here. And so the first example that we have, it's going to be you have to evaluate the integral of x cosine x. So for u of x, it's going to equal x, and v prime of x, it's going to equal cosine x. And so then you plug it into the equation, and then you use the second half of the equation to find your answer here. To determine which is u and which is v, you want to be able to have the integral as easiest to deal with. So yeah, then you get the answer here.
So we have a review slide, and basically it's giving you all of the equations that we just went over in one slide. So we have antiderivative, Riemann sums, trapezoid rule, substitution, integration, and fundamental theorem of calculus. Antiderivative is giving you f prime of x to find f of x. Riemann sums is using an equation that will find the area under the curve for both the left, right, and middle. The trapezoid rule is similar, and it's basically another form of finding the integral using b minus a over 2n, and then plugging in the partitions. Substitution is similar to the antiderivative, and there's this equation is the final one. Integration, again, which we just talked about, which is what? Here's the equation for integration. And lastly, the fundamental theorem of calculus, which is f of b minus f of a. And for our review question, it is f of x equals x squared. And we have to solve using the antiderivative, Riemann sums, trapezoid rule, substitution, integration, and the fundamental theorem of calculus.